Hey guys, my name is Shashank Kalanathi, and I am a data analyst. And today we're here so I can teach you guys all the Python you need to get started as a data analyst. So I actually have a guide for this course out. The link will be down in the description below. And this guide is will provide some information that I may not go over directly in the course. And I think it'll also be very useful because it'll have code snippets that you can just copy and paste into your whatever code editor you decide to use. So let's get right into it. So the overview, what is the point of this course? Python for data analysts, the purpose of this course is to give you the skills you need to get started using Python like a data analyst. And the reason I think that this is important is because when I first started, I actually took just a formal, normal Python course. And it was one geared towards developers. But as I strengthened my skills in analysis, I started to realize that the skills that a Python developer need and the skills that someone who does data analysis or data science in Python need are not necessarily the same. There are some similarities, but a lot of the skills are very different. So this is geared towards getting you up and started with very useful skills you can use to analyze data in Python. Coding, very difficult skill, and it doesn't just come naturally to a lot of people, including myself. And if you're learning how to code, then I highly recommend you set up your Python environment. Follow me and set it up exactly as I set it up, because environments are one of those really weird things that can really slow you down. I remember I actually spent like the better part of a week when I just got started trying to just figure out how to get environments set up. So if you follow me and you do exactly what I do, you shouldn't have any problems. Also, there are going to be some data sets that you should download in order to follow along with this tutorial. And there will be a link in the document that I'll put on the description of the video. One more thing. If this is your first time coding, don't worry, you're just starting your journey. You'll probably need to go through this video at least 2 or 3 times in order to fully understand what's going on. I know when I started, I was in a really, really big rush in order to learn everything as fast as possible. And I got really frustrated whenever I didn't get something immediately. But just know that, especially if this is your first time learning how to code, it's not a skill that just comes naturally to people all the time. A lot of the times it takes a lot of hard work and just watching things over and over and over again. So, without further ado, let's get started. So what is Python and what does it help data analysts do? So Python is a high-level object-oriented programming language. High-level just means that Python abstracts away a lot of the complexity that is actually required to run calculations on your computer. Eventually, everything comes down to little bits and stuff, or binary, and we don't program in that. And all of that complexity is abstracted away. That way you can, if you want to print some text, for example, you just type in print. That's what makes it high level. And object-oriented, it's designed around the idea of objects. We'll be going over objects shortly. That information is really just more useful for an interview, just to tell people you know what you're talking about. I have almost never actually had to apply that knowledge anywhere. It's one of the most popular languages used by data scientists and data analysts everywhere because it's open source, very flexible, relatively easy to learn, and very, very well supported. One of the best things about Python is that there are so many libraries always being created, always being updated in order to allow you to analyze data more quickly, produce visualizations more quickly, and do all kinds of stuff that would normally be much more difficult to code up yourself. It's a very, very well-supported language, and that's one of the reasons I think it's a tremendous language to learn for data analysis and data science. Aspects of analytics that are well-supported by Python and their respective supported libraries include connecting to data. So connecting to data in Python can be very easy. You can use SQL Alchemy to connect to SQL databases. You can use PySpark to connect to big data databases. And I think even MongoDB has its own special connector to connect to its NoSQL databases. You can explore data very easily, and that'll probably be the focus of this course. The focus of this course is going to be on exploring data, and you have SciPy and Pandas that allow you to do that. You can model data using sklearn, which is just a standard machine learning library in Python, TensorFlow, which is useful for artificial intelligence, and PyTorch is another artificial intelligence framework that you can use. You can visualize and present your data. This is one of the really hot spots in Python right now, with tools like Dash, Plotly, Streamlit, all coming up and allowing you to make full web applications with just Python. Normally, to make a web application, you have to know CSS, HTML, JavaScript, and while I wouldn't say that especially CSS and HTML are particularly complicated. It's just another thing. It's another complexity you have to deal with. And web development works very differently from Python coding, which is why having Python libraries that actually abstract away all that code for you is really awesome. All you have to know is that if you want to be a data analyst, Python is one of the best languages that you could possibly learn. R is another great one, but I personally know Python really well, and that's why I'm making this course. So, in order to get started, we'll need three things. So we will need to install Python on our computers, and actually I created a new user on my computer. That way I could walk you guys through the process of actually setting up Python. You'll need something called a text editor, and this will allow you to edit and deploy your code. We'll be using something called VS Code. And you need Jupyter Notebooks. Jupyter Notebooks are a program used by data analysts and data scientists to easily explore data using Python. So let's get started. First of all, we'll install Python through something called Conda. So Conda was designed for data analysts and data scientists, and it makes it really easy to manage all the extra little libraries and programs I mentioned earlier. And what we call environments. So basically you have Python, which is a programming language, right? And there are all these extra libraries that get attached to it. And if you have version 1.0 of one library and version 2.0 of another library, they may not necessarily be compatible. And Conda is really good at helping you handle and deal with this. Pip is something you'll hear about a lot, and that's a very popular package manager also. These things are called package managers. But Conda was specially designed for data analysts and data scientists. And it is, even if you start off with pip, you should probably like move over to Conda at some point in time. So we can download Conda through something, through a visual interface called Anaconda. But I've had hit or miss performance with Anaconda. I had this at one of my old companies. I had what was a pretty nice laptop actually. Just could not run Anaconda. So because of that, we're going to be using something called Miniconda. It is way lighter. It uses command line, which is it's the same. You interact with your computer the same way. You just type out instructions instead of actually like going through a graphical user interface or a GUI. And don't worry, it sounds really complicated, but it'll be very, very simple. I promise. So we'll be using something called Miniconda. So let us go to the official website and download Miniconda. This might just take a second. There we go. All right, so the website should look something like this. And I have a Mac. Obviously, if you have a Windows, go ahead and install the Windows version. Python 2.0 is, or 2.x is an older version of Python that some people still use because of legacy applications. No one should be learning Python 2.x. So I'm not going to be teaching the course on that. You should only be learning 3.x. So as of the recording of this video, Miniconda has support for Python 3.8. This is one disadvantage with using Conda. I think the official the official latest version of Python is actually 3.9 if I'm not mistaken. But I mean, stable release 3.9.2. But for our purposes, it really doesn't mean anything. So I'd rather use Miniconda. So I'm going to go ahead and install the PKG. That's just a little bit easier for me to use. And with Windows, you're going to have to figure out whether you need 64 or 32-bit. I might add something in the instructions on how to figure that out. Let's go ahead and download that. Might take a second. Cool. All right. So the installation process, I'll let you handle that on whatever computer you have. On a Mac, just accept all the defaults, basically. Same thing with the Windows, just accept all the defaults. Let's go ahead and download VS Code. So you can just type in VS Code, and VS Code stands for Visual Studio Code, and it is basically Microsoft's source code editor, or what some people call a text editor. This is different from something like PyCharm, which is like what you call an IDE, or integrated development environment, or developing environment, or something like that. This is less full-featured, but way simpler to use, and I think like more than enough for all the stuff we'll be doing for sure. So it looks like it's just going to take a second. Okay, so we are all installed and ready to go, I believe. Okay, cool. I'm hoping that this is a clean installation of Visual Studio Code. Okay, so open VS Code if you haven't already, and let us, first of all, go to your Finder or, on Windows Explorer, and create a new folder. Let's see, did I say to call it anything? And just call it Python tutorial. All right, and then click on Open Folder, or if you don't see that, go to your menu bar and click on Open, or on Windows it'll say Open Folder. Documents, Python tutorial. All right. Cool. So let us go ahead and set up our Visual Studio Code setup right now. So we need to install the Python and Jupyter extension. So Visual Studio Code by itself doesn't come with many features. We will install a couple of features using the marketplace in order to get it to work better, basically. So click on this button over here. It should be extensions. And then let's type in Python. And you'll see Python is the top one over here. You want the Microsoft Python extension. Currently, we're on version 2021.3. Let's install that. You also want to download the Jupyter Notebooks extension. Jupyter. Okay, looks like I'm having an internet problem again. There we go. Yep, and this one should be 2.5 stars, 11 million downloads. Don't worry too much about it. Yep. Okay, cool. Looks like it's already installing by itself. I guess it might come with the Python extension. So we'll give it a minute. Okay, looks like it's installed now. Awesome. So that's all there. Click on this Documents folder and let us... Oh, one thing I should mention, if at any point in time you're having any trouble getting stuff to work on your code editor, if, for example, the Python library didn't download or something like that, then a really great suggestion would be to go to Google Colab. It's short for Google Collaboratory, and basically it is a way to code Python, especially for data analysts, on Google online on Google servers. And actually, a really cool thing about it is that they give you free access to their GPUs, which you can use to train machine learning algorithms much more quickly. If my internet worked, then I could show you. But basically, go to Google Colab, and when you sign up, you'll see it's fairly self-explanatory how you get to a basic Jupyter notebook setup. Only one L. And then we can file, new notebook. You don't even have to sign up for a Google account. That's awesome. And then you can type in Python code like you normally would. It even has the .ipynb extension that we'll be using later. So this is a great website in case stuff here isn't working. All right. So let us get back to what we were doing. So now you have your environment set up. You have everything you need. Let's actually get started. So basic Python. Python files normally use the .py file extension. And if you see this, then you know you're looking at a Python file. The files we'll be working with are actually called Jupyter Notebooks, and we'll have the .ipynb, IPYNB extension. And they're called this because, the extension is this because they used to be called IPython Notebooks. So Jupyter Notebooks are great because they allow us to combine code, comments, and visualizations all into one file. So it makes it very easy for a data analyst to do an analysis and then present that analysis raw to anyone from your boss to your professor in a very easy to follow format that anyone can follow. And so it's definitely my preferred method for getting a lot of my analysis work done. Although sometimes you will want to use Python files, especially because code completion on Python files tends to be a little bit better, especially in VS Code. And here actually is an example of a notebook that was created by the people who created Jupyter Notebooks. So Might take a second to load. But if we want to get started, then all we have to do is go to VS Code. And let me extend this a little bit. Click on this file or this button right over here for a new file, and we'll call it basic Python datatypes.ipy notebook using underscores. So basic Python datatypes.ipynb. The ipynb, like I mentioned earlier, that's the extension, the file extension for Jupyter Notebooks. And you'll see, it might take a second to get started. Random windows will start popping up. Let's see. So we might have to restart. Okay, there we go. So you'll see down here it says Python 3.8.2 64-bit requires IPy kernel to be installed. What this is saying is, so IPy kernel is actually a library that gets downloaded into Python and allows you to view a Jupyter Notebook appropriately. So just press install right over there. And what it'll do, as you can see over here, it's actually installing the file for you. And we're going to go over how to do this manually in a bit. But VS Code is really good about just getting this ready for you. Awesome. I think we're good now. Okay, cool. So let's get started with the actual tutorial now. So objects, basically everything in Python is an object. Objects are the core of they're the core of the language, and they're what you use to do almost anything in Python. The actual technicalities of objects are worth learning, but they're really beyond the scope of this course because objects get into things like classes and stuff like that. And I think after this course, that's definitely worth learning separately, but it really isn't necessary to get started as a data analyst. I almost never use classes. And while they're useful, I personally don't use them all that much. Variables. So if you're coming in from another programming language, you might be surprised to find out that in Python, you don't have to declare variables before you can assign a value to them. So what happens in other programming languages, oftentimes you have to say, computer, the variable x exists, and then you can assign a value to x. In Python, we just say x equals 5 and x equals 5. So let's go ahead and do that. Let's declare our first variable. So we'll type in x equals, equals 5. And then in order to run a code cell, that's what this is over here. This is called a code cell, you want to hit Shift Enter or Shift Return on a Mac. Awesome. Okay, so it looks like it ran, and you'll even see this little 1 over here. That means that's the first one, or that's the first time you've run a code cell in this notebook. You'll see if I run it again, there's 2, there's 3. It makes it really easy to trace back your steps if you happen to run code cells out of order, and is a cool little feature. So congratulations, you've declared your first variable. And we can check the value of x by just typing in x over here and then hitting Shift Enter. And you'll see x equals 5. This only works in Jupyter Notebooks. We'll call them Jupyter Notebooks. This only works in Jupyter Notebooks. If you were using a normal Python script, like a .py script, then you would actually have to print the value like that. Because if you were just to type that in a normal Python script, it wouldn't work. That's a Jupyter Notebook feature. And definitely one of the cooler features of Jupyter Notebooks. All right, so let's do a little bit of commenting. So commenting is a very useful way to just declare or to just have some notes in your code. And aggressive commenting is definitely encouraged, and a great way to make sure that any code that you write can easily be read and easily be read and edited by other people. So for example, we can go over here and type in hash. This is an integer, and if I run it, you'll see nothing changes. It's because it's been commented out. So the hash is how you comment stuff on a line-by-line basis. There are a couple of other ways to comment stuff. So you can also you can hit Command, or if your Windows, Control / and it'll automatically comment whatever lines you've selected. So for example, like say I was to do like, I don't know, So if I was to have all those lines of code, I could like highlight all of them and then command / and there we go. All right, so the next thing I want to tell you about a Jupyter notebook is something called a Markdown cell. So in Jupyter notebooks, you have two basic cell types that you can use. You have the coding cell, which is, that's exactly what we use right over here. You write code there and, it runs the code. And you have something called a Markdown cell. So that's what happens when you click on this button over here. And Markdown, and when you see when I double click, so it wasn't selected. Now I double click it. So Markdown allows you to, in a more elegant way, comment all over your document. And if you wanted to transform this back into code, then you can just hit this button over here, and it'll turn into code. So the thing with Markdown is it's kind of like a, it's not really a language, but it's like a special formatter that allows you to write out a lot of text in different formats and then convert it to HTML very easily, which is really useful for if you want to show your analysis in a universal format that everyone will understand. So over here on the document, you'll see that I actually have an entire section over here on Markdown syntax, and you can always look it up yourself too. Markdown syntax if you want to learn how to make or how to do something in Markdown. So some really simple ones. If you use a single hash, that's what's called a header 1. If you use a double hash, this is a header 2, and you'll see it's a bit smaller than the header 1. And then you can do triple. This is a header 3. And you can do all kinds of other stuff, So you can, for example, say, this is regular text. You can put 2 asterisks, and that makes that bold text. 1 asterisk makes it italic. One of the most useful things I've used is making bullet lists. So you'll see I hit Shift Enter to run that cell, and you'll see what it does over here. One quick thing to note, you'll notice that I wrote bold text and italic in 2 different lines, but they showed up in 1 line. If you actually want to have a space between them, you have to have 2 enters, like that. Oh, and you can also do numbered points. I should mention that too. How did I do it over here? Numbering can be a little bit finicky. Let's see if this works. Yeah, I believe that worked. Yeah. And you'll see, you have all the syntax you can play with. So Markdown is really useful for whenever you want to actually annotate your notebook and point people in certain directions, explain an analysis, bold some text, italicize some text, and it is one of the, like I mentioned earlier, one of the 2 different cell types we have in Jupyter Notebook. So you have the code cell, which is this one over here, and the Markdown cell, which is this one over here. So actually, doing that, let us create a new Markdown cell, and we'll say header 1, variable assignment, Shift Enter. And then we'll use these arrows to move it up above the variable we just assigned. And you're already editing your first Jupyter Notebook. All right, so the next thing we're going to go over is data structures and data types. So these are just this is the fundamentals of Python. So as you can see over here, actually, so there's a table of contents over here. Basic Python takes up about that much. NumPy is something else we'll be learning, and Pandas is something else we'll be learning. And basic Python is, I try and cover as little bit of it as possible because it is important, but it is not what you're going to be doing on a daily basis. You'll need to understand some concepts and stuff in order to apply them, but there's a lot of stuff that's considered basic Python that you probably will very, very rarely use. Classes being the most obvious example of that. You can accomplish a lot in Python without, or you can accomplish a lot as a data analyst without ever touching a class, or ever creating your own class. Let me put it that way. So I do try and eliminate as much of what I would say is Python that doesn't help you get started as possible. All right, so data types and structures. So there are two basic data types in Python. You have the your primitive data structures, and you have your non-primitive data structures. So your primitive data structures are things like integers, floats, strings, booleans, and I will go over each of those right now. So let us create a couple of Markdown cells. So we'll make this an H2. We'll have an integer. We will have a float. We will have a string. And we will have a boolean. All right. And let us insert a code cell over here. So hover over where you see integer, and then click on this plus over here, and it'll automatically add a code cell there. So an integer is kind of like x equals 5. It is a numeric integer data from this value to this value at least. Depending on your computer, you can actually use more values. So one way we can see if what we created, if x is actually an integer, is by using the type method. So type, let's say x, shift enter, and you'll see it is an int. So that is definitely an integer. They're pretty simple, nothing to mistake about them. I would say if you have a number and you can make it an integer, just use integers. Don't use floats if you can avoid them. Just because it can add a lot of complexity that's unnecessary. You always want to make your data as simple as possible and avoid complexity wherever you can. Whoops. Let us do that. And then a float basically stands for a floating point number, and it basically covers real decimal numbers. So for example, if I was to say y equals 5.0 instead of 5, and then let's put y over there so it prints it. And actually, you know what? Let's do it this way. We will print, and print basically just says, like, print out whatever I'm typing in right now. We will print out the type for the variable y, and you'll see it's a float. So that's exactly what we were looking for. It says class float. Yeah, it belongs to the float class. So that makes perfect sense. Again, fairly simple, no real restrictions on them. I'm sure someone who is more well-versed in programming in general would be able to point out, like, more elegant differences between the two. But for what we're doing, it's like the same thing. And we will actually be introducing more data types a little bit later on. Okay, string. So this is any alphanumeric data enclosed in quotations. Okay, so what that means is usually it's words, but it can be numbers too. So let's say z equals, and then we'll use quotation marks. Goodbye, hello. Oh. And you can see that it wrote that out inside quotation marks. You can also write it out like this. Single quotations work as well. I think. Oh, and you can also use triple quotes. So you'll see it actually creates multiple lines for that quote. This \n over here is what we call a new line, and it is an escaped character. So for example, you're probably asking yourself right now, okay, since I have to use quotation marks to denote that I want to make a string or apostrophes, how do I use a quotation mark in a string? Well, I will show you how. Let's see. Let's say quote equals I think, therefore I am. And normally you would surround this with quotations, and then I think it was Rene Descartes. Well, see, now you have a problem, because we need the quotations inside the quotations. So there's two ways to handle this. Either you can use the single quotes around all of this. Oh, my bad. I guess you can't. Okay, never mind. I guess you can't do that. Oh, you know what? It only works the other way around. So if you want to do that, oh, sorry. No, I see the mistake over here. There we go. So what it did over there is in these text editors, whenever you type in a quotation, you'll see that it automatically adds in a second one. That way it's easy for you to just type it in. So it added two. So or if I do like that, you'll see it adds a second one automatically. Normally very useful, but it can be a source of mistakes as well. So there we go. So that's one way. Then let's print our quote. So that's one way we can do it. You'll see the quotation marks are now in there. Another way we can do it is using something called an escape character. So I can surround this with quotation marks if I want to. And then I can use the backslash key. So you'll see what the backslash key does is that it will tell Python to like ignore the fact that this is normally used to like denote something, this character, and just like print it out normally. But what if I want to have a backslash in my quote? Okay, well, let's try that. I think you can backslash a backslash. Backslash equals, how do you print a backslash? And I think if I just backslash the backslash, then oh, it does it twice. Well, let's see. There we go. Okay. So when you actually print it out, it'll only show you the single backslash. So that actually this is a good lesson over here. The output from just putting the variable over here in a Jupyter notebook is not necessarily the same as the printed output. So this is a very valuable lesson, and definitely something to consider. I still use this almost all the time just because it's way easier, and because this will sometimes render data in a way that makes more sense. But this is definitely something to remember. So yeah, it looks like we solved our problem. We were doing it correctly the first time. All right, so let us continue. Sorry, so this new line over here, so the backslash n, that means new line, that means put in an enter. So like hit the enter key. So for example, if you wanted to, you could do it right here. And if I were to print this out, you'll see it hits the enter key over there. So that's how you handle stuff like that in Python. Strings can get quite complicated, and there's a lot of depth to them. One more thing I want to show you before we move on is the concept of slicing. So slicing is a really great feature in Python that allows you to access certain parts of a variable or an object using just brackets. So for example, let us say I have a string called long string, and that's what it is. But I only want to see the first, let's say 12 characters. What I can do is I can do something, I can put brackets at the end of, so you see how we declared long string over here as long string, here it is. I can put brackets over here, colon, and then type in 11. And you'll see it brings in the first 10 characters, I believe. Let's see, 1, 2, 3, 4. Something important to remember. Python does something called zero-based indexing, which means that this character over here is the 0th character. So you start counting from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it'll leave off the 11th one. If I want to include the 11th character, then I have to make this a 12, actually. So this is how you can use, this is called slicing, and this is a behavior we'll use a lot with something called lists in order to select certain elements from a list. I can also do, so if I don't include a number here, it'll automatically assume I mean the first variable or the first element in a string. I could also do it the other way around, where I could type in 11 and then remove this, and you'll see it includes everything from the 11th index number or the 11th index character onwards. The 11th index character is the 12th character if you were counting normally. So you'll see this is how we can like slice characters, or you can even do like, you know, if you only wanted to do from like 5 to 11, that's what you would get. So this is slicing, and this is a very useful concept for going through lists especially, and you'll be using this quite a bit. So make sure you get familiar with that. Just to make it clear, you can also just put in a single number, and it'll just print out the one element that's there. So in this case, that would be 0L. And that's about it for strings. Next thing would be Booleans. So Booleans are true-false values that correlate to 1 and 0. And you would basically declare a Boolean by saying, I think you can, okay, cool, I can call it that. So I can't call a bool, yeah, I can't use the word bool. So this is a, I forgot what they're called, but it's basically like a term that's like saved in Python, and it means something in the language, so you can't use it to name variables. But we can use Boolean. That is a Boolean. The word true. Now remember, this is not a Boolean. This is a string because we use these quotation marks around it. So you want to make sure that you don't use quotation marks around it. Another one would be, there's only two really. False. And you have to write it exactly as it's expected. Python cares about things like capitalization, as you can see over here. So you have true, you have false. We will be using this later to help us filter data out. I don't think there's anything else to do with Booleans. Oh, another thing. You can use Booleans to help you compare two different values, and that's usually what they're used for. They're used to compare multiple values. So, for example, if we say A equals 1 and B equals 2, and then we say A is equivalent to B, in Python, this equal sign over here is how you declare and assign a value to a variable, and this double equals is how you say is equivalent to. Then you'll get a false because 1 is not equivalent to 2. If I was to change this to a 1 and run it again, you'll see we get true now. We'll be going over these in a little bit too. So now we're going to go over non-primitive data structures. These are the really interesting ones. There's a lot of like small minutia with these, with integers, floats, strings, but for the most part, they're fairly simple. There's not too much to go over with them. But now we're going to be going over non-primitive data structures. So these are things like lists, arrays, tuples. You think they're pronounced tuples, they're actually pronounced tuple. Dictionaries, and sets. So let us add some Markdown over here. Non-primitive data types. Whoops. Let's correct that. All right, so the first one is a list/array. So Python does not actually have an array type per se. You call this an array in many other languages. What we're going to call a list does more or less the same thing. So a list is nothing more than, kind of like a list of objects. You just combine a bunch of objects into one object. So we'll call it the A list, and you make a list by surrounding it in brackets. So for example, you could type in, 1, 2, 3, 4, 5, 6, 7. And that is a list. So a list, you separate each individual value in the list using a comma. That's very important. This is something that's very interesting about lists too. You can combine data types. So you'll see we were able to combine integers, these are integers, with our string over here. So that's something you can do in a list. And lists can be sliced the same way strings can. So a list, let's see. So a list equals that. I want to get the number 5. So that's this one over here from the list. So what would I actually put in there? Remember, Python follows zero-based indexing. Pause the video and see if you can figure it out for yourself. Okay, so in order to get the number 5 over here, which, you know, if we're counting normally 1, 2, 3, 4, 5 is the 5th value, we actually have to put in a 4 here, and we get the number 5. And that's because the first value is actually the 0th value. That's important to remember. We can also get get a couple of values like that by using that colon over there. By using the colon over here, we can say go from here through here, excluding that, but including that. So it includes the first value and excludes the last value. Another interesting thing you can do is you can go negative. So I can type in -1, and it'll count backwards. So it'll get the negative first value. The reason this isn't -0 is because, you know, -0 is not a real thing. So -1. That would be this value over here. -2 would be the value prior to that. And then, you know, you can go all the way up to, you know, -6 or something. Another interesting thing, this is actually a common interview question. People will ask you, how do you reverse this list over here? Usually this is for developer positions, but an interesting trick that you can do in Python is to use double quotation or double colons, -1, and you'll see the list is now output in a negative manner, or in output in a reverse manner. And what is happening here is that normally we write it like this, right? So it's saying go from here to here. So this means go find all the values, because go from 0 to the last value. The next colon, what's past that tells you how, like, what to count up by. So for example, if I make this a 2, you'll see it counts every second value. So it starts over here, and then it'll get 3, and then it'll get 5, and then it'll get 7. When you do -1, you're telling it to go backwards. That's the logic behind that trick, and it's a fun little party trick for people sometimes. I find it's a relatively unknown trick, so something to keep in your hat. Oh, also tuples. Yeah, so tuples are literally lists. They just cannot be modified. So a_list, or well, tuple equals, and then we'll do 1, 2, 3, 4, 5. A tuple. 1, 2, 3, 4, 5. Very simple. I wonder if you can reverse this actually. A tuple. Well, can you index it first? Okay, so you can index it. So this is called indexing or slicing. Okay, so I guess this works, because what this is doing is this isn't actually modifying the tuple. This is just producing a new one that counts backwards. The only thing you have to know about tuples is that they are just like lists, except they can't be modified. And a coworker of mine actually explained it really well. The main use that she saw for these things is that they're used as like outputs for Python classes and methods. But I have like never used one before. This is probably the second time I used one. The first time was when I learned about them. The second time is when I'm teaching you guys. So good to know, but you know, just use lists. Okay, dictionaries. So dictionaries are key value pairs, and they can be quite useful when working with tables. So we'll get to tables in a minute. We're just going through all the basic Python stuff right now. So a dictionary, let's see. You declare it using curly brackets or curly braces, and it needs to be like a key value pair. So for example, key, colon, value. And you'll see, you know, the colon might be confusing because we used to use this to mean like go from here to here. This is kind of just stuff you have to memorize. In different contexts, different symbols mean different things. And this is just one of those things you'll memorize. Don't worry if it seems like this is really difficult right now. I'd say just write it out. And then like as you use it more, then you'll start to learn, you'll start to pick it up yourself. It's all about application. The idea behind this course is to just give you the raw knowledge you need to be like, okay, I like know how to do this and I know how to do that. So that's what we're going for over here. All right. Yeah. So, and if you want like another key value pair, you hit comma and then another value. And that is a dictionary. They're really, really useful. Oh yeah, some stuff about dictionaries. You can use, so let's call this something, dictionary. So you see dict is how you declare dictionaries, so I can't use that. So dictionary equals that. So when I hit this over here, dictionary, you'll see that it creates a key value pair, another value, and they're separated by a comma. So the next thing would be, okay, you can also slice dictionaries the same way. Well, let's see. I guess you can't. Where did I put that? Oh, sorry. You can't slice them like that, but you can like search up values. Like if you put key in there, then you'll get value. So if you put this here, you'll get this value. There's no easy way to get the keys out of a dictionary. That actually requires you to. There's a little bit of like fancy stuff you can do with for loops in order to get that. We're not going to go over that in this course because that's just again a bit more of a party trick and not something that's particularly useful for you to know now. You can also use something called the get method. And you'll see it pulls value again. And you heard me use the word method. I'll go over methods in a minute. Oh, and a set is basically an unordered, unchangeable way to store multiple variables without duplicates. So it's basically this. There are no duplicates. That's the important thing about sets. Again, another thing I almost never use. Although I do use them more than tuples. I have used a set before. All right, operations. Okay, so this one's going to be a doozy. So this is where I'll teach you all of the basic mathematical operations you can handle inside Python. I think we have arithmetic operators, assignment operators, comparison operators, bitwise operators. There's quite a bit of stuff here. So we'll buckle up and let's get started. All right, so let's get to Python operations. So this section was very heavily inspired by W3 schools, and they're a tremendous resource for all things Python. The idea being that there's only so many ways to teach this kind of stuff, but they have one of the best ways to teach it. Okay, so let's try arithmetic operators. So arithmetic operators are just, simple addition, subtraction, division, multiplication, what you're used to. So if you add two numbers together, for example, let's say, add equals 2 plus 2, we'll call that add. You'll see it's as simple as 4. But if we were to add two strings together, let's see, str plus strr, add string, then you'll see it concatenates the two together. It just sticks them both next to each other. This is tremendously useful and something that I use quite a bit, honestly, just like attaching strings to each other. Adding lists. You'll see it just sticks the two lists next to each other. And it creates a new, bigger list. That's actually quite important. Instead of like inserting this list as a last element in another list. That being said, I actually do wonder what would happen if you did that with tuples. I've never done that before. See, you guys have me asking all these questions of myself I never would have asked before. Okay, I guess the idea is that it creates a new tuple. That's why it can do that, but you can't modify this and this. Again, you see why I never use tuples. They're really just, like, in most cases, they operate the same as lists. Subtraction works as you would expect. You cannot subtract strings, as far as I'm aware. So let's try this. Sub str equals str minus strr. And as you can see, you cannot subtract strings. You'll get this thing called a type error. And the great thing about Jupyter Notebooks is that they will actually point you exactly to where the error is. So, obviously this is a one-line code cell, so it's obvious where the error is coming from. But when you have more code, then it becomes less obvious, and this is a tremendously useful feature to have. Okay, so next, multiplication. So, with numbers, it works exactly as you'd expect. 3 times 2 equals 6. With strings, it works very interestingly. What you'll see is it actually triples a string. So it'll if you take str, like that string, and then you multiply it 3 times, you'll get str, str, str. And same thing happens if you were to do this with a list. So try list equals there you go. As you can see, it just, sticks 3 lists on top of each other. Exactly like you would expect. It's the same thing as what is multiplication apart from just repeated addition? That's exactly what we're doing over here. We're just adding it over and over again. Division works as expected. Let's see, 2 divided by 2. But one important thing, and then also division will also create floats. That's an important thing to remember. When you see this decimal over here, you know it's a float because a normal integer won't have that decimal at all. Another thing that is important to remember is in Python, you'll get something called the zero division error if you try and divide by 0. So you can't divide by 0, and this is an error that we'll learn to take care of in the near future. Modulus and floor division are the 2 other types of basic arithmetic operators I want to go over. A modulus, again, this is something you'll actually find yourself using quite a bit. Modulo equals, let's go with the example I gave, 10 modulo 3, modulo. And what it does basically is that it is dividing 10 by 3 and then giving you the remainder. So I'm not too sure why they don't call it like remainder division, but it's just called modulo. And then floor division So what floor division does is it tells you what is the greatest multiple of this number into 7. So for example, like 2 can be multiplied up to 3 times and still be less than or equal to 7. So that's floor division. I'm sure it's very useful. I haven't really used it that much, but I'm sure it is very useful. Okay, assignment operators. Oh, yes. Correct. So assignment operators are very simple. Basically, you just this allows you to quickly recalculate and assign a new variable. So instead of saying x equals x plus 3, you can do x plus equals 3, and what happens is that equals this over here. It is basically only useful for making your code shorter. That's the main use of it. But it's definitely something I'd take the time to learn. I didn't put any examples because there was basically no better way to explain it than the way they explained it. Now we're going to go do something called, we're going to work with comparison operators. So comparison operators, if you remember earlier, we actually worked with a comparison operator somewhere. Command F equal. There we go. Yeah, here we go. A is equivalent to B. Not the same thing as A or A equals 1. A is equivalent to B. Basically, comparison operators allow you to compare 2 different values, and then they will output true or false depending on what's up with the values. So let us copy this. Okay, and I will just write a bunch of print statements here. Come on. All right. And you'll see, yes, 3 is equivalent to 3. So that's the true. 3 is, so exclamation mark equals means not equal to. I wonder if you can also do... Okay, so you can't do that. I believe you can do that in SQL. So yes, 3 does not equal 4. Okay, so the third one. 3 is greater than 4. That is obviously untrue. So that's false. 3 is less than 5. That is very true. Excuse me. 2 is greater than or equal to 2. That is true. And 4 is less than or equal to 4. That is also true. So, you'll see over here, This is just a very simple way to compare different values to each other. And this stuff doesn't really sound particularly useful right now, but don't worry. We're going to be applying all of this to something called Pandas, which allows us to compare, millions of rows to millions of rows, and that's where you'll start seeing this is very, very useful stuff. Trust me, I'm only teaching you guys what you need to know. All right, bitwise operators. Right, so these are better explained by the Python website. The full logic behind it, I don't fully understand. There's just some stuff that you need to remember. This AND operator over here does something and something, like do they both equal each other, then the output is 1, otherwise it's 0. And this is an OR operator over here. This will come way later in the course, but I'll make sure to make a note of it when we come over here. And these are just useful to remember. Again, these are a little bit more advanced, and you don't need them to get started, but they're useful to remember and have in your back pocket. Logical operators, so you can use these to string together different comparison operators. So like, 3 equals 3, or 3 is equivalent to 3, and 2 is less than or equal to 5. Those are both true, so it'll return true. 3 is equivalent to 3, or 2 is less than or equal to 2. Well, this is true, and this is false. So if at least one of them is true, then OR will return true. And then not will basically return the exact opposite. So this is the same as the first one, which was true. So everything in here is the same as the first one, which was true. But because I have this not over here, it returns a false. Membership operators. So this is interesting. What happens is, you have a string T, for example, right? You can see T is definitely inside T, but I'm pretty sure I didn't type, well, I definitely didn't type in a 1. You'll see that's false because 1 does not appear here at all. And then obviously the exact opposite is also usable. 1 is not in that. I believe I can also, okay, so you can't compare an integer and a string. Although one useful trick you can use is that you can wrap a lot of objects around in parentheses and then type in something like str to turn it into a string. Or you could wrap, for example, like 5.0, which is actually a float, in something like this, turn it into an integer. Or you can wrap 21.1 and, oh, sorry, that's already a float. And then you can wrap 21 in that and then turn it into a float. This is just a useful trick to have up your sleeve that you can like transform data types like this pretty easily. So yeah, the 1 as a string is not inside that. That is true. So these are just operators that, want to blaze through them. Very, fairly simple and, just good to know. But not really the crux of what we're doing. All right, so the next one is functions. So functions are really useful if you find yourself writing the same code over and over and over again. And what they can do is that they can make it to where you write a code just once, like a block of code just once, and then you call on that block of code over and over again whenever you need to. So in order to declare a function in Python, what you do is you type in def. I think it means define. We'll call ours function underscore name. And underscores are just good practice inside Python. Make sure you don't have like spaces because it won't recognize that as one entity. So when you have a space over here, this isn't recognized as one entity. So use underscores for everything. And then let's go X, Y, Z, and I'll explain this in a minute. Return X plus Y plus Z. So what we're doing over here is we've defined a function called function name. So we'll call this something easier. So define our function with inputs X, Y, and Z. And then return X plus Y plus Z. So I would call it and use it by doing this. I would be like, okay, So let me make sure I ran that. Nope. Our underscore function, and then I use parentheses. I want x to be 1, y to be 2, and z to be 3. Shift enter, and you'll see we get 6. So what I did is I called our function, which we defined up here, and then x is 1, y is 2, and z is 3, and then returned x plus y plus z. You can also specify, and these are called arguments, you know, the stuff we put inside the function, we call them arguments. You can also specify the arguments like this. X equals this, y equals this, z equals this. If you don't specify it, then Python will automatically assume the order that you put it in is the order you want to declare the argument. So it'll automatically assume the first one, the first argument you put in, is the first one over here. The second one is the second one. The third one is the third one. What you can also do is you can also do it like this, declare only one of the variables or declare only one of the arguments or two of them, as long as the ones you didn't declare come before. Or you can do, but you can't do the exact opposite. So for example, you can't do x equals or that and then not define the other ones. And that's because Python doesn't know what position these are at. It can't assume that this is the second and this is the third one, because some functions have like dozens, if you know, not, well, I don't know about hundreds, but they have dozens of arguments. So very important to remember it. Unless the function is very simple, it's honestly a good practice to declare your arguments. Another thing. Oh, yes. You can write a more complicated function. So you'll see what happens is I hit enter and my ID or my and VS Code automatically put this tab in here for us. So you'll see there's a tab there if I hit tab. And that's because indentation is very important inside Python. This indentation tells Python that everything like indented here underneath this function before return is belongs to this function over here. So I can also type in x equals 3, y equals 2, and then no matter what happens, when I run this again, oh, sorry, I have to make sure I run this first. That way it knows that's what it is. And I run this, you'll see I'm getting 8 right now, because what's happening is it's taking in x equals 1, y equals 2, and z equals 3, but then it changes x to be 3 and y to be 2. So now we have 3 plus 2 plus 3, which 3 plus 2 is 5 plus 3 is 8. Makes perfect sense. Functions are a very important part of any well-written Python script, and are just, it's a beautiful thing to have, because they can take what would be, you know, hundreds and hundreds of lines of code and like condense into like 12. And another big reason you want to use them is because sometimes you will make changes to your functions, and instead of changing every single instance of like a code block you've copied and pasted, now you only have to change the function once. So I highly, highly recommend you use them, and they're tremendously useful. All right, let's see what else we have. Okay, cool. So we have 2 more major concepts in relation to basic Python. So we're going to be going over something called libraries and installing new libraries. So like I mentioned earlier, in Python, libraries are kind of the core of what make it such a versatile language, and why, at the end of the day, you know, people talk about what's the next big data analysis or data science language. Python and R are here to stay, because the number of libraries being created for Python every day is just it's crazy. So you need to know how to install these libraries. That way you can use their functionality whenever you want. One important thing to remember is that the Python you have, it probably, like when you download it, it won't have a lot of the features that you want. So that's where we'll use something like Anaconda, you know, Conda, the mini Conda thing we installed, in order to manage our libraries. And as we use them, they'll become more familiar to you. What I'm saying right now sounds like gibberish, but when we start applying it, it'll make more sense. So if you have a Mac, go ahead and open your terminal. I hit Command Space, and then I just look up terminal. You can also go to the Finder. You can go to Applications, Utilities, and hit terminal over there. If you're on Windows, then hit the Windows key, and then type in Anaconda, and you'll want Anaconda prompt. In case that's hard to see. Might take a second to load. But type in Anaconda and just look up Anaconda prompt. There's also Anaconda PowerShell prompt. I just get Anaconda prompt. As per usual, this is incredibly slow. This might work a little bit faster. In case that was hard to see. But basically, you just hit the Windows key and type in Anaconda, and that'll be the best way to do it. You can access Anaconda through the normal command prompt. It's just a little bit more difficult to get a hold of. There we go. So that's not going to load for a while, so we'll leave it as is. Okay, so, these steps are the same for everyone. So let's see. Oh, you know what? If you just installed, let's see, let's type in Conda, ZSH command not found Conda. Oh, okay, so I must have actually not downloaded or not installed Anaconda on this computer. Okay, give me 1 minute. Let me go ahead and, I thought I... Yeah, this is what I mean by environments can be a huge pain to deal with. Okay. Hey guys. Okay, so I was not kidding when I said that environment issues can be a real pain in the butt. So when I created a new user, there was just a bunch of like issues with where I'd like put Anaconda and everything. But either way, if you have a clean install of Anaconda, it should work just as expected. If not, the issues can be so nuanced that I can't really help you with them in this video. But there are a lot of resources out there in order to help you with your specific issue. So assuming you have Anaconda installed, and you opened up the Anaconda editor in Windows or in or just the regular terminal on a Mac, you should have something that looks kind of like this. It'll say base in parentheses and then a bunch of stuff after that. Type in Conda and hit enter. If you get no errors, meaning that it just shows you all this stuff over here, then everything is working as expected. So let's go back over here. This is not going to load. And let us install a package called NumPy. So NumPy stands for Numerical Python, and it is one of the premier packages for, or it is the premier package for just like any kind of numerical, like mathematical operations you handle in Python. So in order to do that, we type in Conda. So that's the application we're using. We're using the application called Conda. Install. That's the command. And then NumPy. And hit enter or return, and it'll start looking for the package, and then you'll get a proceed y/n, hit y and hit enter, and it'll start installing NumPy for you, and you'll see it finished installing NumPy for you. So it looks really complicated, but essentially what it's doing is it's just installing a bunch of different applications into a folder. That way you can access them and access all of their functionality whenever you need it. So let me show you how to import a library. Go to the bottom of your file and then type in import NumPy and hit shift enter. No module named NumPy. Okay, so what that means is that usually means I'm using the wrong version of Python. And in VS Code, an easy way to find or to get the right version of Python is to go up to this upper right corner, click on it, and you'll see all the installations of Python you have on your computer. You should not have this many. I have this many because of just because of different projects and stuff like that. So if you have a Mac, Macs come with version 2.7 installed in them automatically. Never select that. You never want version 2.7. But especially if this is a clean install of Python for you, it should work immediately. And then find the environment that you are using and click on that one. I know for me, this one will work, so I'll use that one. And then there we go. So import NumPy. So what we did is we installed a library, and now we have imported it into our Python file, which means that we can use it now. Usually what you actually want to do is you want to do this. Import NumPy as NP. NP being just an alias we're giving NumPy. That way we don't have to keep typing in NumPy.this, NumPy.that. And what I mean by that is in Python, you access different functions of a library. The functions of a library are called methods using a period. So for example, np.array is numpy.array. Obviously I have to put something, yes, and I do have to put something inside here. You know, so now I've created what's called a NumPy array. You could also do it like this. And in documentation, you'll see that they write out the full name of the library because people can alias it whatever they want. Like I could literally call it by, and then that would work. So, but by convention, you should use np.array or np. That way, anyone that reads your code knows exactly what's going on. If I see np, I assume it's NumPy. And this, you should follow standard conventions for that reason. Okay, so yeah, that we've imported a library, and we've unlocked a world of functionality with that, which we'll play with a little bit later. Methods, like I mentioned earlier. So array is a method of the NumPy library. That's what this dot over here means. So NumPy, so class dot method. That's just more so you know what we're talking about when we say method. It's not particularly important. All right, control statement. So let me shrink that a little bit. All right, control statements. So control statements allow us to repeat operations in Python, but they can also do a lot of other stuff too. So the first one, and the one that I personally use the most, is something called a for loop. And what it's basically saying, it's almost like English, for I in. So first of all, let me create a list. You need something called an iterable or a list, and a list is a type of iterable. So we'll create something. We'll call it the list, and we'll call it the range function. So what range does is range will give you all of a list of values from here to here, counting up by 1. It's very useful if you just need to make a list of values from 1 to 100. Oh, and in order to print it, you have to turn it into a list, which, remember, we can do just by surrounding it with the word list. So you see 3, 4, 5, 6, 7, 8, 9. I can make this 100, and it'll go from 3 to 99, as expected. But we do not need to do that for now. I just wanted to show you guys what exactly we did there. Okay, so now we're going to do a for loop. So for, and then pick a random variable. I is usually what people use. So for I in the list, colon, and look at what happens when I hit the enter key. Enter. You'll see Python automatically indented it for me. Like we did with the function, this basically tells Python that everything at this level of indentation underneath this is a part of this loop over here. So for I in the list, and we're going to use that operator I showed you guys earlier, I plus equals 1. So what this does is that this will add, this will say, this is the same as saying I plus, or I equals I plus 1. Exact same thing, except we're just saying in a slightly shorter format. Print I. So what's happening over here is that the for loop is going to start at the first element. So for I, so for every element inside here, perform these actions. So it starts off at the first element, which is a 3, right? So for I in the list, so for 3 equals 3 plus 1. So print out 4. Okay, cool. Next, it goes from 3 to 4. So 4, the number 4, in the list. 4 equals 4 plus 1, which is 5. And what it does is it does that over and over again. It keeps iterating over it. So a way that I can illustrate it more simply is print, I is now, and then we'll just print the value of I. And then we'll type over here, output is, so when I is 3, after we perform all of our calculations, the output is 4. When I is 4, the output is 5. And you'll see I goes from 3, 4, 5, 6, 7, 8, 9. So it's basically going from 3 to 100. It'll go until we get to 99. So that's what a for loop is. Incredibly useful. If it doesn't make sense, just break it down and go over it a couple of times, but very, very useful. You'll use them a lot. One common thing I use them for is to read a bunch of files from a directory. It is just a very simple way to handle all kinds of like repetitive tasks in Python. Next, we have something called a while loop, and a while basically will repeat itself while some condition that you define is true. So if we say x equals 0, okay, while x is less than 5, again, we use a colon, hit enter, and it automatically puts this tab for us. And I can demonstrate over here. So you'll see loop has ended doesn't show up because it's not indented. It'll only show up at the end. After it's finished this for loop over here, then only it prints out loop has ended. But if I was to hit the tab key over here, you'll see now loop has ended gets printed on every single row. Okay, so back here, while x is less than 5, let's just say x plus equals 1. Print x. Oh, whoops, you know what? That was an error. So I accidentally created an infinite loop. So you see it went on forever. And when that happens, you can hit this stop button over here, and it'll stop the kernel, and it'll stop whatever's happening at that moment. So, because I wrote this incorrectly, it should be plus equals. And then, so that's something you have to be very careful about, especially with while loops. While loops have a tendency to be easy to create what you call an infinite loop. That's something you have to be very careful for whenever you're programming. And you'll see, because of a typo, I accidentally created an infinite loop. This one wasn't that big of a deal, but some of them can get quite bad to where they start slowing down your computer. So definitely something I'd watch out for. If then. So if then is basically like saying, if this condition, then do this. So I'll just copy and paste the example I have right over here, because it's a very good one. So x equals 3 and y equals 5. So if x is equivalent to y, print x equals y. Elif is short for else if. In Python, we write elif. Elif x is greater than y, print x is greater than y. And then else is just the final condition. So if both these conditions fail, then do that one. Print x is less than y. So you'll see, because 3 is less than 5, it hits our else condition, and x is less than y. Very simple if else, if then statements or if else statements. In a lot of other languages, you have to write out the word then. In Python, you don't have to. The indentation automatically tells you, if this happens, then do this. Else if, then do this. Else, then do this. Try except. This is really interesting, and this will help you block a lot of errors in our code. So if you remember earlier, when we did 2 divided by 0, we got something called a 0 division error. So what try except does, so try will basically say try this code, except when you receive a certain error. So try 2 divided by 0, except when you receive a 0 division error, then instead print can't divide by 0. And this is a great way to like engineer around exceptions and errors in your code. So you'll see, instead of printing 2 divided by 0, 0 division error, it says, it prints out can't divide by 0. Very simple. These are pretty useful for when you're writing more robust code that you don't want to just break on you like that. the with statement, this is an interesting one. Bit difficult for me to explain, but there's a great explanation I linked over here on Geeks for Geeks. This, again, tremendous website. But basically, it is used to help make sure that you, when a condition is done, any processes associated with it stop too. So a really big one is making sure that when you open a file, so with open this file over here, and we're just calling it reader, print file is read. After that happens, it'll then close out that file and make sure you didn't make sure that the file stream is not kept open. That is definitely more useful. That'll be more useful later in the course. We will actually be using a different method in order to open and close files. So that is just a quick overview of basic Python. Now we're going to go over NumPy, and I believe NumPy, we only have a couple of things here. Yeah, NumPy can actually get quite involved, but for the sake of what you need to know, I actually think Pandas is way more important, and so we're going to quickly go through NumPy and then continue on to Pandas. So let's save this, Command S, create a new document, and type it in we'll call it NumPy tutorial.ipy notebook again. And by no means is this supposed to be a thorough tutorial. A thorough tutorial of like Python would take like, I don't know, like 10, 12 hours. And I don't think it would really benefit you. There's no reason to know everything. There's so much documentation out there and there's so many resources out there. Learn what you need to learn in order to get your job done, or to, learn enough to move to the next level. So now we're going to go through NumPy. So NumPy, or numerical Python, is a Python library that undergirds almost all of Python's advanced mathematical and statistical functions. You won't be interacting with NumPy directly most of the time. You'll usually be interacting with libraries that interact with NumPy or are built on top of NumPy. But I just thought I would show you guys how it works. So when you design a normal Python script, if you remember back here in our previous one, we did this import statement like over here towards the end. You very rarely import stuff at the end. You almost always have your first lines be your import statements. So we're going to import the NumPy library as NP. And you'll see, same problem over here. So I click here and I click on the environment that has NumPy inside it, if you remember from what I did earlier. If you did a clean install of Python, that should not be a problem. And let's create a NumPy array. So a NumPy array is basically a list. It's just written in C. I forgot which version of C, or if it's just C itself, and is much, much faster than a Python list. That doesn't really matter for when you're just starting, but as you start to do more and more advanced stuff, you'll want to use NumPy arrays instead of lists because they're way faster. So as you can see, we're creating a NumPy array. So we're accessing the array method of the NumPy class, which we imported, and assigning it to variable A. And you'll see it just creates an array. Oh, and you cannot do the below. So yeah, this is a good example. So you need to make a list in order to create an array, or you need to like give it a list or some other iterable. So if you did this, for example, that is, yeah, that's because what's happening over here is that because you didn't put it in, like this is one object. The list is one object. And if you remember from earlier, there are a number of arguments that you can put into any given method. A method's another word for function, but it's a function related to a class. And each of these is a different argument. But over here, because all of this is inside a list, this is one argument. So that's why it's saying array takes from 1 to 2 positional arguments. So, in our case, we just put in 1. So 1 to 2 positional arguments, but 3 were given. So that's why you can't do that. If you ever see this type of an error, it usually means you didn't put in a list where you were supposed to. So this is wrong. Don't do that. Okay. So another thing you can do is you can reshape NumPy arrays. So NumPy arrays can be any number of dimensions. The one we just created is a one-dimensional NumPy array. A two-dimensional NumPy array is essentially a table, as you'll see over here. So this is basically a table, and you'll see two sets of brackets, right? So you have this like inner set in here, so 2, 3, 4, 5, 6, 2, and then this outer set over here. And what we did over here is we created an array with 6 values, and then we told it to reshape, so dot reshape, 2 rows, 3 columns. Don't worry too much about this. This is not something you're going to be messing with for a while. I just wanted to put it out there. That way, when you see it, you're like, oh, I know what that is. And then over here, you can even make a 3-dimensional array. And you'll see we have 1, 2, 3 brackets over there. Again, don't worry too much about this. I just want to make you aware of what's going on over here. And with NumPy, you can do all kinds of calculations with it too. So you can so we created an array over here called E, numpy.array, 1, 2, 3, 4, 5, 6, E.find the sum, E.find the minimum, find the maximum, find the mean, and then print all those values out for me. So this will be used a little bit more, a little bit later in the course. But, this is, again, these are just like, I'm just stringing together I just use dot and then sum. And I'll show you how to look up, like, what are all the different stuff you can use. Because, for example, you might have tried to type an average over here, right? Which, makes perfect sense. But there is nothing called average. You have to know what specifically to call. And that's where the documentation is incredibly useful. And I'll show you how to use documentation with Pandas a little bit later. Then you can create a bunch of what I call special case arrays. I would say the most useful one over here is the random one, where you can create a random one in linspace, where like linspace creates an array from X to Y in Z even spaces. So, for example, you'll see it created an array from 0 to 6 in 10 equivalent spaces, which is, 2/3. So go up by 2/3, go up by 2/3, go up by 2/3, stuff like that. np.random.rand, this creates 3 random values from 0 to 1. This can also be quite useful, and you'll see every time I call it, the numbers change. I'm not too sure what randomizer it's using. You can also do random int, and then it'll give you a random integer between 2 different numbers. That's also quite useful. This is useful in this might be useful for A/B testing, in order to randomly assign people to different groups of, different groups, basically. And then np.arange, this is very similar to the range function we had earlier, where it just creates a range from, because we didn't specify 0 to 25. Oh, and np.zeros just creates an array of zeros. This is useful. I personally haven't used it, but I've seen use cases for it. The reason I sped through all of that is because I just want you to be familiar with it. It's not too important to understand it right now. Pandas is where the meat and potatoes of this course is, and it is what we will be working on next. All right, let's get started with the Pandas part of this tutorial. So, you've completed all of the preliminary work necessary to understand Python to enough of an extent to where you're very much dangerous, and you can do a lot of the data analysis work you'll need to know. Now, what you'll actually end up doing half the time is applying a lot of these data analysis techniques to a library called called Pandas. Now, Pandas stands for panel data, and it is basically a library in Python built on C that's designed to help you quickly explore, clean up, and transform and export data that is in a tabular format, also known as structured data versus unstructured data. So, first things first, let's install Python. Let's install Pandas. So terminal, we open up the terminal again. If you're on Windows, open up Anaconda terminal. And we'll type in conda install Pandas. And you'll see we'll get the same YN. We do want to proceed. And while that's working, let me tell you guys about a video I created, where in this video I actually go over a real life problem that I worked on, and I solved mostly using Pandas, and I got paid real money for it. The point being that once you've mastered the skills in this course, you should be able to do something similar to that task. So you can go through this lesson and then go watch me transform data in such a way that a client I was working with, like, they needed the data, put in such a way. So very useful skill, and I think that is a great way to learn it. All right, so now that we've installed Pandas, let us import Pandas. Okay, awesome. So let's create a new script over here. We'll call it pandas tutorial.ipynb. And I think you guys will like this part of the tutorial because this is where it all kind of comes together and where you start to see the usefulness of what we've been learning. To be 100% honest, like lists, tuples, integers, floats, that really is not useful for data analysis by itself. It's when you combine everything together inside these more powerful libraries that you start to see the power of Python. So let us import pandas as PD. So like we used to import NumPy as NP, we're now importing the pandas library as PD. Cool. And let's get started. So the core of pandas is something called a data frame. And a data frame is basically a table, except it's a little bit more powerful. So it's kind of like an Excel table, but more powerful. And every pandas table, every pandas data frame is composed of a bunch of series. And a series is an indexed list of numbers. A little bit different from the list we're used to. So let me show you guys what I mean. So we will call this, let's create a list. We'll call it series test. And you know what? Let's get fancy. We will create a list of a range of function or a range of numbers from 1 to 100. Oh, sorry. Remember, this is supposed to be a comma because we're inserting two different arguments. So remember, range, the range function, goes from 1 to 100, and we're converting that to a list. Cool. And you'll see it outputs like that. All right, now let's turn it into a series. All we have to do. So you guys remember how we used to go like np.array in order to call the array method of the NumPy class? Now we're going to do pd.series. And important thing, series, the S has to be capitalized. If it's not, you'll get an error. So make sure the S is capitalized. Cool. And what it did over here is it created something called a Pandas series, which is of length 99. Makes sense. And the D type, the data type, is int64. So this is what I meant earlier in the course when I said we're going to be working with more complex variable types. Things like Pandas and NumPy use like int64, int32. I'm not going to go over them in this course because, again, it's not important for for you to like get started. I really don't want to bombard you with a bunch of irrelevant information right now. But as you look through the documentation, you'll start to see the difference in these data types. So this is what a series looks like. You have the actual data over here, and you have the index over here. Remember, we start off as 0 as our index. So this is the 0th point. 0.1, 0.2, 0.3, 0.4. 0.98. And that's a series. And what a data frame is it's literally us taking a bunch of these series and just stacking them columnar-wise next to each other. And that's why one thing some people will say, especially if you look at Stack Overflow, is that you are encouraged to run calculations on columns in Pandas. And I believe this is the reason why that's the case. All right. So data frames. Okay, so we have almost entirely created our own data throughout this entire process. Let's work with some data that already exists. We're going to be doing this using the read underscore star method of Pandas. And that could be like read CSV, read Excel, read Stata. It can be any number of things. So let us download the data needed for this course if we already. All right, so let us just go through the basic. Okay, so yeah, let us download the data needed for this course. So You should already have that downloaded. That's actually part of the, it'll be in the link in the bottom of the YouTube video. It'll be like a Google Drive folder. I do not. And we're back. Okay, so I went ahead and downloaded the files that come as part of the package I'll put on the YouTube, on the description of the YouTube video for you guys. And we're going to be worrying about simple CSV over here. So let us import simple CSV. And if you don't know what like a CSV is, there's a small explanation over here. Basically, it's well, I can actually show you guys. You can see over here, it's a text file where every row is separated by what we call a new line, and every column is separated by a comma. There are other versions of this format. There's like pipe separated files where you separate everything with like these pipes over here. There's tab separated. And the things that we use to separate every column, we call that a delimiter. So, quick little lesson for y'all. Okay, so let us get started. So, go back up to your import statement over here and import something called OS. Import OS. Shift Enter. And then let's add one more code cell and type in pwd equals os.getCwd. I'll explain what this is in a minute. So what this is OS is basically a library that it comes default with Python, but you have to import it into your scripts where you're using it. And basically what it allows you to do is it allows you to like access different functions and stuff inside your computer. So what I'm doing right now is I'm telling OS to get the current working directory, which means the directory that this file is stored in. The reason I wanted to do that is I want to set that as a variable. That way, whenever I tell Python to go looking for a file, I'll say the file will be present working directory plus the name of the file. The reason I do this is because that way, when I move my files around all over my computer, this will always tell the Python script to like look where it is right now and extract the file from there. And that's what we're working with. As you start to, when you mess around with it, you'll start to see what it does. Basically, a directory is a set of folders that we like. A directory is just another word for folder, and it's a folder that we're in inside your computer. And you have to make sure. I've had problems before where I can't pull up a CSV because my Python script thinks it's in a different directory than I'm actually in. And ever since I started using this, I've never had that issue. So, and PWD stands for present working directory. I believe that's the Windows term for it, actually. Never mind, that is the Apple term for it. So that's why I use PWD. All right, so that was a little bit of a diversion. Let us create a string called file path. So you guys remember how when we wanted to concatenate strings together, so for example, when we wanted to do, we literally just added them like that and it just like stuck them together. Well, that's what we're going to be doing to create a file path. So what we'll do is we'll create a new variable called file path, and we will call it, we will say pwd, present working directory. That's our directory over here. And actually I can show you guys. You guys can see it's showing the directory that we're in. So present working directory plus or / simple underscore csv.csv. That's this file right over here. So you see what it did over there? It added a / simple underscore csv.csv. This is our file path. This is what we're going to be looking for. Or this is where we're going to look for the file that we're going to import. So you should have, I mean, yours will obviously look different because your computer's different from mine. But it should be fairly similar to this. Okay, cool. So I'm going to comment that out. And let us import our CSV. So in Pandas, it's super simple. We will call it our first import, because we're importing our data. First underscore import, that's our variable, or our object. And we will say pd, pandas, dot, read underscore CSV, parentheses. And now we have to put in the arguments for our method. So let us, the first one is file path, which is just file path. And I think that's about it. Then I'm going to put in first import over here and then shift enter. And you'll see our data comes in exactly as expected. Now, this is actually a case where you want to make sure you use, just type in the variable name instead of writing in print, because look what happens when I write print. It comes out in a bit of an uglier format, and this is how Python normally renders the data frame. I honestly prefer it to look like this. So we're going to, and this is like one of those functions of a Jupyter notebook. You know, you'll see you have the index over here, this nice line. It just looks very nice. And when you start looking at enough data, the way it looks is very important to you, at least for me. All right, so congratulations, you've imported your first file. Now, you might be asking, how did I know that file path goes over here? Well, this is where we need to start looking at documentation. So documentation, because there are so many libraries in Python, it's absolutely impossible for someone to know how every single argument of every single library works. And this is where documentation will help you figure out, okay, what do I put here? What do I put there? And I still use it even for libraries I use regularly because I'll like not remember what goes where. And Pandas luckily has tremendous documentation. So let's open up a new tab on our internet browser and literally just type in Pandas documentation. Then you should get redirected to Google. You know what? Maybe that's actually the problem. Going to Google from... Okay. So you'll see it's almost always the first result, and it looks like this. So this is the newest version of Pandas. We are not using that version, I believe, but it doesn't matter. It's all like, it's more or less the same thing. There aren't going to be any major updates to like a lot of the major methods that we use. And then I believe we want to click on user guide. No. Reference guide? You know what? Here's a better way to do it. Just type in pandas read underscore CSV. This is what I'm looking for. Yeah. Okay. So yeah, and you'll see it doesn't say pd.readcsv. It says pandas.readcsv. That's because, you know, like I mentioned earlier, we shortened pandas to pd, but it's still technically pandas. And here you see pd.readcsv, and you'll see it has like 12.5 arguments. You know, there's absolutely no way anyone's going to memorize all of this, and it's really important that you don't try to, honestly. You just have to know what these, you just have to know to come here whenever you need to like try something new. So you can do all kinds of stuff when you import your files over here. One really cool one I like to use is nrows, which stands for number of rows. So Control F, nrows. Yeah, you'll see right over there. By default, there's nothing there. Nrows, what it does is it will tell Pandas to only import the number of rows. So it's really useful for when you're reading large files. That way you only read like the first 1,000,000 rows at a time in case your computer can't handle reading it all at once. So I can go over here and I can say, since the first argument is file path, which is, you know, that's where is the file. It makes sense that that's the first argument. I'm actually going to type in nrows over here equals, and we'll just type in 10. And you'll see it only brings in 10 rows. All right, so let's go back to our notes and see what's next. Yeah, here I explained to you how to like actually read something in. Oh, this is supposed to say Excel. And so, for example, when you're reading an Excel file, right, Excel files have multiple tables to them. So how do you specify which table? Well, there is a sheet name argument we can mess with and specify which sheet we should use. And it's beautiful how simple this library is to use. It's literally just read underscore CSV arguments. Here are all the arguments, and here they are cleanly laid out for you. Easy to read, easy to understand. It really is amazing how fast you can do stuff with Python. All right, so let's start taking a look at columns. So, we have our data over here, first import. You can specify a column using dot, I don't know if you call it dot notation, but you can do first import dot column1, and you'll get the first column of data. I never do this. I always use the secondary form of denoting a column, which is putting it in brackets. So your data frame brackets, so data frame brackets, and then naming the column. And the reason I do that is because a lot of the times columns will have spaces inside their names, and this makes it really easy to handle those types of situations because everything is inside this. It's in this string over here. And this is where it can get a little bit confusing. These brackets do not denote a list, but this is a string. Don't ask me why. That's just the way the API was written. So that's just something I want to make sure I make clear to you guys. All right, so let's say we want to create a new column. If we want to create a new column, it's as easy as going first import, and then we name our new column something. So we'll literally call it new column. And then we say, what does new column equal? If I say 1, then you'll see what it does is it literally just adds 1 to every row. I can also say first import new column. Oh, well, no, let's do new column 2 equals, and there are 10 rows over here. So I can provide a list of 10 different values. So a list range 10, and I think that should work. Awesome. Worked exactly as expected. If I provide something that's longer, then you'll see it errors out because you get a value error because the length of values 12 does not match the length of the index, meaning that you provided more values in that list than there are rows in the column. So let's make that a 10 again. Let's see, what else? You can add columns very easily to each other. So you can go, let's create a new column. We'll call this added output. And then we'll make that equal to this column plus this column. There you go. 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. And so on and so forth. Another thing you can do is you can drop columns very easily. So dropping is just a term that they use in relational databases, meaning it basically means delete. Same thing. Well, okay, it technically is not, but it's similar to getting rid of something. So I can do first import equals, so the first import data frame, this data frame equals first import dot drop, and oh no, I don't know what goes inside the drop method. Well, that's where our documentation comes in very useful. Search the docs, drop. And, as per usual, it's going to take forever to load. Pandas.dataframe.drop. That's what first import is. First import is a data frame, but remember we created it by saying pd.readCSV, so it's actually a pd.dataframe. So that's what we'll use. And then, for the sake of time, I'll just tell you that columns is what we're looking for. We can specify which columns. So I can say columns equals, and then I can either give a single label or a list-like thing. A list-like just means like a tuple or a list or something similar to that. I want to drop, let's go with new column. Oh, I forgot my underscore. And you'll see we dropped new column. It used to be there, and it's no longer there. All right. another thing that I want to make clear to you guys also. This is a little bit confusing. So in Python, there's like always more than one way to do stuff, and in Pandas that's no different. If you want to drop a column, a lot of the methods can be used directly. So for example, you don't have to say first import equals take first import and drop that column. You can just say first import, so that data frame dot drop, and then we'll use the same columns method. Columns argument, new column, and then we're going to use an argument called in place. So actually, let me show you what happens if we just do this. So you'll see it didn't actually drop that column. New column is still there. See? Well, that's because what happens is this command ran, but I didn't set it to equal anything. So I dropped the new column, but I didn't set it to equal anything at all. So what I can do is I can actually do in place equals true. And you'll see now it dropped the column because in place is just an argument that tells it, yeah, if it's false, return a copy. Otherwise, the operation, it'll do the operation in place. And the default value is false. But I set it to true over here. So we're going to be using that quite a bit. All right, now that we've done rows or columns, let's go ahead and do rows. Rows can be a little bit more complicated to deal with in Pandas. Pandas is really meant to handle things in a columnar fashion, but obviously, you're going to be handling rows quite a bit. And to handle rows, we'll be using something called the LOC and the ILOC method. I call them lock and iloc. Although to be 100% honest, I don't exactly know how they're pronounced. So the lock method allows us to use the names of columns to specify them. So for something like this, we go data frame, so whatever the name of our data frame is, .loc, and then we use these brackets over here, which, can be confusing, but, it is the way it is. From row to row. So from row, like, say, 0 to row 30. And then here are all the columns of data you're going to be pulling. So let's try and pull the first 5 rows of data using this. Whoops. So the way we do that is we go first underscore import dot loc bracket. And then from row to row. So I want to go from row 0, so I don't have to put anything there, colon, row 5. That'll bring the first 5 records. Oh, and there's something with LOC that you'll see pretty soon that can get kind of confusing. Comma, the second argument. So the first argument is which rows you want data to come from. The second argument is a list of all columns that you want to include. So in this case, I'm going to just copy all of these columns. I want all of them. I want all the data. Oh, whoops. That was supposed to be a... So what I'm doing is I'm just highlighting them and then adding quotation marks, and VS Code intelligently adds it around whatever I've highlighted. After I got used to this feature in VS Code, I kind of wanted Word to do it, but Word just replaces everything. All right. So this is something that for some reason lock works differently in this way. So lock will include the index of the last number you specify. So 5 over here. In every other instance in Python, that is not what happens. I will be honest with you, I have no idea why lock works like this, but it's just something to remember. What I often use more, well, I guess I use lock quite a bit. So I use lock whenever I'm doing a data analysis and I want to be very, very certain of the columns that I'm pulling, because column names don't change that often. But in iloc, we use something called the index of the columns, and those can change all the time, because if, new column is index 3, but you insert a column right before it, well, now it's index 4. But it's always going to be named new column. So That's why I prefer to use lock a lot of the times, but iLock is kind of easier to remember and easier to use sometimes. Let's see, is there anything else I need to go over here? No, that's about it. Okay, so let's go over iLock. So first, underscore import. Let's try to do the exact same thing that we did with lock. So we want the first 6 rows, really. So what we'll do is we'll go 0 to 6. Yes, makes sense. That's the first argument. From what row to what row are we looking at? And then I want all the columns. So from what column to what column based on the index. And you'll see we get the exact same answer. Now, here's the difference over here. If I put it in like a 0, you'll see it brings in the first column because I'm indexing the column. If I remember, I have to provide a list because the second argument is the list of columns. So if I give like 0 and 2, you'll see it brings in the 0th column and the second column at index 0 and index 2. And you'll also notice that, it's indexed differently here. This is how everything is normally indexed. I don't know why lock works the way it does. There's probably a good reason out there, but either way, it's annoying. So that's lock and iLock. These are this is the main way you can like limit the amount of data, look at only certain data, and pull up sections of data in your when you're playing around with stuff. So I would make it a point to remember the first argument is the rows, the second argument is the columns. All right, so let's get started working on some real data. So the data set that I have in the folder that you guys downloaded is netflixtitles.csv, and this was created by Shivam Bansal on Kaggle. So Kaggle, for those of you that don't know, is a website supported by Google that basically has a bunch of companies and people putting up real data over there so that people can try their hand at modeling it and seeing what relationships they can find and seeing if they can optimize for a certain column or predict the number of predict what factors most likely lead to credit card fraud, stuff like that. And it's a great place to go get data sets. I highly recommend it. So you should have a netflixtitles.csv in your folder. Let us import it. So we're going to just use Netflix equals pd.read underscore CSV. And again, remember, we're going to form that file string, the string of the file path. So present working directory, that string we identified at the beginning, plus / Netflix underscore titles.csv. All right, let's see what we get. Looks good. You should get 7,787 rows and a bunch of columns. Oh, actually just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 columns. When we're counting, we shouldn't start by 0, just when we're indexing. All right, so I'm just going to run through a couple of quick things that you can do in Pandas. These are rapid fire because they're relatively simple. It's just methods you have to remember whenever you want to do something. So oftentimes there will be more columns than you can see in one screen. Luckily, in this instance, we can see all of them. But what you'll want to do if you want to get a list of the columns, you type in netflix.column. So whatever data frame you want. Dot columns. And you get what's called an index object, which is not quite a list, and it doesn't always operate like a list. So what you oftentimes want to do is, like we always do, just surround it with a list like that, and it immediately converts to a list. Perfect. Now, what if I want to get summary statistics on all numerical fields in this data set? Well, Pandas has a very cool function for that, method for that, sorry. So we're just going to call it netflix.describe. And you'll see there's only one numerical column here, and it's release year. This gives you the count, mean, standard deviation, minimum, 25th, 50th, and 75th percentile or quartiles, and percentiles. And and the maximum value. So this is just a very quick way to get summary statistics on your data. I think I can also do... Yeah, so this will return something called a correlation matrix, which measures, I believe, the Pearson correlation coefficient, basically how correlated different variables are to each other. But because we only have one numerical value, that's not going to happen here. If you want to see all the unique values in a column, so for example, I want to see, we have this column called type. So far, I only see TV show, movie. This means there's a bunch of data here, movie, TV show. But I can't be for sure that the only values in this column are movie and TV show. So let me run a method that'll tell me exactly what unique values are inside this column. So we specify the column we want. How do we specify columns? Well, first, we type in the data frame, bracket, and then I believe it was type. This is our, yep, that's our column. And then dot, another method, unique. And there you go. You're getting an array, and it says TV show and movie. That's it. Those are all of our unique values. So yeah, that's just a very easy way to do that. Say you want to filter a data frame. There are a couple of ways to do this. The way I like to do it is by, I think it's called like Boolean masking. Yeah, it's called like Boolean masking, I believe is what the term is. So you type in the data frame, and then in brackets, you type in the data frame again, but this time you're specifying a column. Go on. Netflix, and then I'm going to specify country as my column. Or is equivalent to, remember, not equals to, is equivalent to. And then I want to get all movies from Singapore. And you'll see with this index column over here, we're building up a bunch of different indices. And you'll see we only bring up, if you look at country, movies from Singapore. Actually, funny thing is I found that there is a movie credited to West Germany here too. Yep. Just an interesting concept to me that, yeah, so I was born after Germany became Germany. It's just crazy to me that there was an entire, period in history where Germany was not a country. But anyways, if you want to use multiple conditions, then you can use this @ symbol that I mentioned earlier when with like bitwise operators. So I'm just going to copy this over here. And what this does is, you know what? Let me type it out. So we want to filter the Netflix data frame. So we'll put a bracket over there. And then you need to close in parentheses every condition you have. So I'm going to have two conditions. So there's one, there's two. And I want both of them to be true. So I'll put an and in between them. Now, let me specify that I want movies from Singapore. Or sorry, I want media from Singapore. So that means I have to specify Netflix country, the country column, like we did earlier. And I want to say is equivalent to Singapore, like we said earlier. Remember, capitalization is important. And I want the rating to be great, or well, sorry, I can't do that. To be equivalent to TVMA. I only want mature shows from Singapore. And there you have it. It's the exact same as just filtering one thing, except make sure you surround everything with parentheses, each condition, and just put an and in between them. If you wanted to do an or, that's just a pipe, like that. And that gives you an or. So you'll see that brings in a lot more stuff, because that'll bring in stuff from like Egypt. But it's TVMA. So. All right, so DateTimes, DateTimes, they're going to give you a lot of pain as a data analyst. I'm going to go over them very briefly because parsing dates, that could be an entire video by itself. So we'll go through it pretty briefly. So the good thing is Pandas makes it really easy by kind of, it can like take dates in various formats and kind of like intelligently figure out what you mean. So over here, we have this date added column, which has the date, luckily, in an unquestionable format. Now, if you've worked with data from the United States and, not the United States, then you'll know that, like, some people write their dates like this. Let's go with that. or so in America, this is how we write our dates. Month, year, day, month, year. Whereas the rest of the world, they do day, month, year. So we do month, day, year. They do day, month, year. Basically going in, from the smallest unit to the biggest unit. If I had to guess the logic behind why we do this in the US, is that like sometimes you just want to know what month it is. I don't know. But it's important to know that, for example, say you had a date like, this. It's not really possible to actually know what that date is and what format that is. Which is why I always recommend writing your dates in this format. Because as far as I know, this is the only way. When you write dates like this with the year first, it always goes year, month, day in that case. There's no... I don't believe there's any other way to... I don't believe anyone ever writes year, day, month. Although I could be wrong. But this is how whenever I pull data from SQL databases, it's always in this format. Either way, luckily, we have the date formatted in such a way that you can't really confuse it. Because it's, obviously the month. Then that has to be the day. And then the year. So, Pandas will be able to very simply figure out what this data is. So, computer date equals pandas, so PD, dot to_DateTime, and then you provide it with the series of the column you want to convert. So that's this series over here. And how do we specify a series or a column? You do the data frame, and then the column name. And then I should probably... And there you go. 2020-08-14. 2020-08 August 14th. It translates it into this format, which I believe is the only way to write that. But again, I could be wrong about that. Now, we also did end up with a couple of what are called NAT values, means not a time. And I don't believe we've gone over NAN. So you'll notice these NANs over here. NAN means not a number. And basically, it is similar to a null. It just means there's no data over there. This can be a major problem with a lot of machine learning algorithms, a lot of statistical algorithms. And it's something you definitely want to handle if you can. So I can tell you, I know that this column has NA values. And so I'm going to tell you how to fill that in. So we're just going to fill it in with values that are just January 1st, 2020. Also, let's make this a column. Let me add it to our notes here. That way, when everyone sees it. So we'll add a new column instead of making a different variable for some reason. And if you find any typos or anything on my notes, feel free to reach out to me over on YouTube, and I'll be glad to fix them. I don't want anything incorrect being there, but something is bound to happen. Awesome. So now let us fill in the NA values. So we're going to import a library called DateTime. That should just be a standard Python library. And then we're going to take the Netflix computer date series / column that we just created. And we're going to use a method called fillNA. And we're going to use this thing called DateTime. So that's a DateTime. Well, actually... Let me show you guys something. So from DateTime, import DateTime as DT. So this is actually a common way to write this. So what that's saying is it says go to the DateTime library and then import the DateTime method and then call it DT. Because you'll see what I did over here is I didn't do that. And I actually, I had to write DateTime.DateTime because that's just how the library works. And this means that I should just have to write DT. And that should equal DateTime.DateTime. And we're going to do 2020-01 well, I can't do 01, and then 1, 1, and then I believe I have to do in place. So now, what that did is this fill NA method, it fills in all the null values inside the data frame over here. And let me prove to you that those values were actually null. So let's create this column again. I ran this cell over here, and so I created this computer date column, right? And then so I'll prove to you that there were null values in there. I feel like I shouldn't just tell you they were in there without showing you how to find out for yourself. Okay, so you'll see 7,787 is the length. If I use a method called drop NA, where it drops null values, you'll see we end up with 10 fewer values. That's not that many, but that can still be a problem. And you'll see later it actually does become a problem. So the drop NA will drop any NA values in something. So that's why I wanted to fill in the NA values in there. And remember, NA is basically null. They're technically different, but they're pretty much the same. And then also I want to tell you about something called Unix time. So this is something that you'll notice in a lot of databases. And Unix time basically is the number of seconds or nanoseconds, depending on how you're counting it, away from the what's called the Unix epoch, which is January 1st, 1970, I believe. I forgot the exact reason for that. But basically what happens is, like, it's an integer number that goes up once every second, as you'll see over here. Seconds since January 1st, 1970 UTC. So that's a GMT. And this is a format you'll see in a lot of databases. Like data will be stored in this format. And the reason probably just has to do with, like, it's a format that can't really be confused with. It's very, very simple. And so if you wanted to, like, have the Unix time, it's just as simple as creating a new column. We're going to call it Unix time. And we're going to say it is equal to computer date dot as type int. So the as type method allows you to change the data type of a certain column. So then you'll see when we look at this over here, there we go. So yeah, this Unix time is actually using nanoseconds. That's why there are all these zeros back here. But normally a lot of them use only seconds. Yeah, so that's just Unix time, a quick diversion, because if you mess around with enough databases, you'll see that quite a bit. And it's important to know that, like, oh, that's just how time is written in some databases. All right, what else do we have? Ooh, joins and unions. That's going to be interesting. And then pivoting and melting data. Okay. So we have some content left over. So next we're going to be working on splitting columns. So something that you'll encounter quite a bit in a data frame is you sometimes want to, like, take a column and then, like, split values away from each other. So for example, like, values would be written with commas inside them. So let's see. An example over here would be, okay, so say we didn't have the release year. Oh, actually, no, that doesn't even matter. Okay, yeah, perfect. So the date added and the release year are obviously two very different dates. And if I wanted to know how many years from release a movie or a TV show was added to Netflix, I need this date value. I need this year value over here. And in order to get that year value, I have to split it away from this column over here, which I can, if you look, you can see I can split it using that comma over there. I can say, hey, Pandas, when you see this comma, split this column in two. So that's exactly what we're going to do right now. This is a very useful technique for expanding your data and getting more data where data didn't exist. All right, so what we did over here is, let's go over this part first. So we're taking the Netflix date added column right over here. We're taking that column. And we're doing a string split. So when we do, like, .str, so we're taking every string .str .split, and we're telling it to split it. And we're saying, okay, split by this comma and this space, because I also noticed that there's an extra space over there. I want to get rid of that as well. And when I do expand equals true, then what happens is it'll, like, create new rows. So let me demonstrate. you'll see it created one row called 0 for that, and one row called, or sorry, one column called 0 for the first part of the split, and one column called 1 for the second part of the split. Say I had left this at false, as it is by default. Then what it does is it actually gives you a list where every item is split by, like all the splits have like commas in between them. So basically this is saying there are 2 items in this list and the commas over there. So we don't want that. We want this to be true. And I want to make a new column out of it. And I know I'm going a little bit fast, so don't feel like this is the speed you're supposed to understand it at. I would just like to keep this video under 3 hours if possible. Of course, if you feel like I'm going too fast, feel free to like reverse and go over it as many times as you need to. I'm going a little bit faster to see if I can beat 3 hours. So what we're doing over here is, when you notice over here, it splits into 2 columns. So I have to actually provide 2 different column names in order to I have to provide 2 different column names for Pandas to create. So that's what I did over there. I provided a small list of columns, and then you'll see at the end, date part 1, date part 2. Awesome. All right. So we created, we took that date column and we split it into 2 different parts. Now you may, okay, we call it date part 1 and date part 2. Okay, yeah, so one other thing that you might, maybe we want to call date part 2 like a year or something. So what we can do is we can use a rename method. This is how we rename columns. So Netflix.rename columns, and then you provide it with a dictionary. So the dictionary, the key is the current column name, and the value is what you want to change it into. And in place equals true, so we're going to do this in place. Let's see what we get. And you'll see date part 1, everything is left as is except for date part 2, which got transformed to year. Nice. So you'll also notice that there are a lot of NA values in this data frame. But let's focus on only one column for now. So under cast, there are, like here, for example, there's an NA value. And I want to change that to say something and not say NAN, because you'll notice you can't perform a lot of transformations on data that's like at NAN. So you want to fill it in a lot of the times. So I'm going to use this method over here, where we're looking at the cast column, Netflix cast, .fill NA. Fill NA is the method we're using. And we're going to fill it in with a value called no cast, meaning that it'll literally just say no cast. In place equals true. And you'll see down here that NAN got filled in with no cast. Fairly simple. And you can also, what you can also do is you can also provide a list of values that is the length of this array this series, in order to like say, okay, replace like the first value with 3 and the third value with 4 or something like that. Occasionally you'll want to do that, but in this case, we're not really looking to do that. All right, so there is another. This is a bit more of an advanced use of Pandas, but it's really cool and very useful. I use it all the time. So sometimes you want to take a function or some series of like steps and apply it to every row of a data frame. So for example, like I want to count the number of genres that a film is in. How do I do that? Well, okay, I have to. So we're gonna when I say genres, I mean the listed in column. So we're gonna have to take this listed in column, split it out by commas, and then get the length of the list that comes out of it. Because remember, when we split out data, then we can, either if we can either split it out into brand new columns, or we can tell it to go in a list, and we can count the length of that list, how many elements are in that list, to see how many genres we have. So in order to do that, I need to have a quick aside where I tell you guys about lambda functions. If you guys remember functions, you remember earlier we went over them. They were stuff like this, where, you define a function, you define what arguments go into it, and then, you do some transformations and you return a value. So a lambda function is just a function that works on a single row. So I can call this function the adder. And what it does, you type in lambda x colon, and then it'll do whatever you tell it to over here. So I can say the adder, and you'll see, yep, it added these two numbers together. So it's really simple. It's just a way to write a function in one line, and it's a lot cleaner sometimes when you need your data to be a little bit cleaner. So what we can do is we can actually use lambda functions to map a function or apply a function across an entire data frame. And there are two methods we're going to learn here: the map method and the apply method. So the map method is going to be, you only use that whenever you're going to pass a single element. A single series as your, what you're mapping to. So if I want to do stuff to only one column, like this, like cast over here, then I will use the map method. If I want to do stuff to multiple columns across the data frame, not necessarily every column, just multiple columns, then I'm going to use the apply method. So here is a function I have in order to find the number of genres inside for a given film. So we type in Netflix bracket genre count. So that's our column, and that equals the column listed in. Remember, I said that was kind of like a genre column. And since we only have one series over here, we're going to map a function to it. And the function, we're going to use a lambda function, lambda x, length. So len gives you the length of whatever's inside it. So for example, if I was to this is a string, remember, not a number. There are 9 characters there. So that's what length helps us out with. And you can even do it with you can even do it with a list like this. 8 elements in that list. So we're going to be using the length method over here. Sorry, length function? Length something. We're going to be using the length something to take. So what is x over here? So x in this situation, what Pandas is going to do is it's going to take Netflix listed in that column, and this map function is going to say pass in every element of the listed in series one by one. So give this first, then give this, then give this, then give this. So what it's saying here is Netflix listed in dot map lambda x. So x is going to be each of these elements over here. And again, don't worry if you don't get it immediately. This took me a while to understand, honestly. Like none of this stuff makes sense the first time around. So don't worry too much about it. You just need to be aware of it. And then we're gonna take x, which is a string, and we're gonna split it. I believe I just did it that way. And what you'll see is, you'll get 3 genres, 2, 2, 3, 1, and that counts a number of genres, because what it did is it took every single value. Actually, you know what? Here, let me demonstrate this, what it does for you. So you'll see it creates a list of every single value in that got split up, and it makes every split a different element of that list. So when I take the length of that list, then we get a number, the length of the list, which is the number of genres. So you can use splits a lot for a lot of different things. Now what I want to do next is I just want to show you guys the apply method. The apply method uses the exact same logic Except you apply it directly to the data frame. Notice how I don't put a column over here. I'm applying it directly to the data frame. And that allows, now what happens is Pandas is passing, like X, every X it's passing is actually a row of the data frame, which is why you need, cast. So you need X and then specify the data frame and then specify listed in, etc., etc. And this is a nonsensical column where basically I'm adding the number of cast members and the number of and the number of genres in a movie. It doesn't really do anything. It's just to illustrate the point. All right, now we're going to get into some of the really juicy stuff: group bys, aggregations, and sorting values. So a lot of the times you will receive data in a really, really big format where there's just too much data to do anything with, and you don't actually need all of that data all at once. So in that situation, we're going to use a group by in order to take, for example, all Singaporean movies and then collapse them into one row. So let's go ahead and try that. Let's say I wanted to get a count of the number of Singaporean movies in this data set. What would I need to do? I would need to take every Singaporean movie, and I would need to count every title, every movie title, over here, because we're assuming the title is a unique value. It may not. It actually show ID is probably better. Yeah, so we're going to take every show ID, and we're going to count that. Actually, let me... There we go. We're going to count every show ID for a given movie. And you know what? I feel like this is one of those things that should be explained with an example. Oh, okay. Well, I think there's probably a good one online. Not one available right now. Oh, you know what? I can probably just use that. Yeah, this is a problem with using new account. So what we're going to do over here is 1, 1, 1, 2, 2. Actually, even better. So what we're going to do is I'm going to illustrate how you would like group by some data. So for example, if I wanted to group all the hellos together, then and sum all of them together, then I would end up with a table that looks like this. Yes and no. And then this equals is I'm assuming that these functions work the exact same way as. Oh wow, this looks a lot better than Excel. All right, so what I did over here is I grouped by column 1. So there's only one instance of every value in column 1. And then I aggregated by a sum of column 2, where I took the sum of every value in column 2. And so that's what we're going to be doing over here, except we'll be using a count, I believe. So let us do that. I want to count the number of movies, or the number of media per country. So I'm going to go get our data frame over here. So Netflix dot group by. I'm going to take the data frame over here, and I'm going to group it by. Let's go with the country column. And then what happens is now you've grouped the data by the country column. You need to specify what column you want to aggregate on. So I want to aggregate on the show ID column. And then I want to get a count. And you'll see when you do it, you come with this like funky format over here. Don't worry. All we need to do is we need to do .reset_index. Because what happened over here is it created something called a GroupBy object, which is it's just a different type of object, and reset index turns it back into a data frame. And you'll see we have a nice clean data frame right here again. So in Argentina, there were 50 shows. Of course, some of these, it looks like there were some joint countries over here. So if you wanted to count this accurately, you do a lot more, many more transformations. This is how I knew that West Germany had 1. So Vietnam has 5. And yeah, that's how you do a group by. And then now we want to sort our values. So I want to know what country makes the most movies, at least in terms of like, that are on Netflix. It's going to be the US. I can tell you that right now. So what we're going to do in order to figure out what is the in order to sort all these values is we're going to use something quite literally called the .sort _ values method, and it's going to be by show ID. So what column am I sorting by? And then if we go over here into the documentation, we look up sort values. Then you'll see by default, it sorts the values ascending, meaning it goes 1, 2, 3, 4, 5. What I really want is descending because I want to know what has the most movies. So I want it to go from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. So on Netflix, there are 2,500 movies that are from the US, 923 from India, 397 from the UK, Japan, South Korea, goes down and down from there. So that's how you group by values and how you sort values too. So this is a great way to get information that wasn't otherwise available to you. It's kind of like a pivot table, although we will be going through real pivot tables a little bit later. Awesome. Oh, and sorry, I was supposed to also mention Pandas, as you can see, makes it very easy to just stack. So here's something. I can bring this over here. And you'll see it gives me the same result. I took this sort values, I just like stacked it at the end. I smashed it at the end of this reset index. Pandas, for the most part, allows you to just, attach command after command. And it's really good about that. So it's a really cool way to do some really quick transformations with your data. And it's a really cool feature of Pandas. All right, so next we will do joins and unions. So oftentimes we want to enrich our data by performing things called joins and unions. So a union is literally taking 2 data sets and stacking them on top of each other. A join is taking 2 data sets and putting them together horizontally, as these glorious illustrations I made for my Tableau course display, and they show. It's called a union in SQL, so that's what we're going to call it here, even though the method we're going to be using is called a concatenate. I think union is probably the term that's more common amongst people. Like, people are more familiar with that term. So in Pandas, it's super easy. We just use the pandas.concat method and provide a list of data frames we want to concatenate. So let's import our second data set. We're going to call it second _ data set equals pd.concat pd.read _ CSV, and remember, present working directory plus Netflix title second. All right. And literally all I did is I just like chopped off a section of it. So this just allows us to, demonstrate the pd.concat method, which is the same as just stacking data frames on top of each other. So new data set equals pd.concat, and then we provide a list of data frames. And there you go. You'll see that we've added a bunch of rows to our data frames. And we were in the 7,000s earlier. Now we're in the 8,000s because we, joined a bunch of, or we unioned a bunch of rows together. And this list of data frames can be as long as you want. You can add as many data frames as you want. It's a really great way to just add a bunch of data all at once. Next, we're going to be doing something called joins. These are a little bit more complicated. So we're going to go in depth on these because this is a very important concept that people have to understand. So joins allow you to combine two tables horizontally. For a join like a union, you need to have at least two tables, and we call one our left table and one our right table. So you can imagine when we combine two tables together, one's going to be on the left and one's going to be on the right. So you'll see over here, I'm combining a left table and a right table. And there are four basic types of joins you can have. You can either have an inner join, a left join, a right join, or a full join. What this is saying is that an inner join will take all the data that is common between two different data frames, and it'll only include columns, it'll only include rows that have common data. And you'll see what I mean in a minute. A left join will take all of the rows in the left data frame, regardless of whether they're common or not, and then add whatever rows from the right data frame are common. The right join does the exact opposite. I never use right joins because I just use left joins as a I don't know what you call it, but like it's something I do, and it's just something I do with my data, so people know never to look for right joins. I'm always doing left joins because these two things are basically the same thing. And then a full join just means smashing the two tables together, regardless of whether data matches or not. So you'll mostly be sticking to left and inner joins, and it's worth your time to learn more about joins because they're some of the most powerful tools you can use to enrich and manipulate your data. And I use joins basically every single day at work. It's a very, very useful skill, and it's something that takes more than one day to understand. Especially if you're not familiar with data, it's a very different way of just thinking about how you combine stuff together. So, for example, let's say I wanted to join these two columns or these two data frames using the ID row. ID column, the ID column. Well, there's only one ID that's common between them. So if I did an inner join, then it would join like this. ID, color is blue, that's from the left table. Model is 30x, that's from the left table. The ID right, the ID from the right table. And then the car, which is from the right table. A left join, if I was to again join on the ID column, will keep all data from the left table and then whatever matches from the right table. So you'll see in this case, ID 1, 3, got to keep both of those. But we're only bringing in the car model or the car name 1. That's ID 1 because we don't have an ID 3 or an ID 2 in common between these two tables. And then a right join just does the exact opposite of that. 3 is not common between them, so we leave that out. And then a full join, you'll see, will bring together the data as it can. But for example, there is no correlating value for number 2 over here. So you'll see all of these values are null. But it'll still give it to you in the final data set. Some common gotchas with joins are duplication of data. That's probably the most common thing. If, for example, you want to do a inner join, and you're using ID 1, well, looks like over here, the right table has 2 ID 1. So what's going to happen is it's going to duplicate this 1 blue 30x row twice because it has to match every instance of 1 with every instance of 1 over here. So that's something to watch out for. It's not necessarily an error. I sometimes want to duplicate data, and in those situations, it makes perfect sense to do that. So that's just a quick overview of joins. Now let us go back here, put you over there. And again, don't worry. Especially if you're new to data, stuff like joins doesn't really make sense the first go around. It took me a couple of months to learn that actually. when I first started. So don't worry too much about it. As you work with it, you'll start to get it. Okay, so what I want to do now is I want to take this Netflix movies by country data that we created over here, and I want to match every country in this data set, like the total number of like shows, with all of the countries over here. So we're going to use something called the pd.merge method. So we're going to call this Netflix underscore merged. Yeah, equals pd.merge. There is a join method in, and again, join is the term that we use in SQL. That's why, I translated it over here. Again, my understanding is that join is the standardized term. I'm not too sure why they use merge, but, so Netflix merged equals pd.merge, and we need a left table. We need a right table. We need to tell it how to join. So do we want an inner join, a left join, a right join, and then we need to say join the left column on and join the left data frame on which column. So like which columns do you want to start matching together, and join the right data frame on which columns. This is the standardized format I use for all of my merges. Just makes it a lot easier. So we want to take the Netflix data set. I think it's actually called... Oh, sorry. No, it's a new data set. My bad. New data set. That's going to be our left-hand table. Our right-hand table will be Netflix movies by country. And for anyone wondering how I'm finishing that, whenever it suggests something, how I finish it, I just use the tab key. That's how you complete code. How I want an inner join. No real reason, just that's the way we're doing it today. And we're going to join it. I always like to give it a list of values, even if it's just a single value, on the country column. And that'll be the same for both of these. All right. And you'll see over here, there we go. Show ID. And it added that Y over there because if you see over here, we never renamed that column. You guys know how to rename columns. I'll let you guys do that in your own time. So it just calls it show ID Y because two columns can't have the same name in a Pandas data frame for, obvious reasons. You wouldn't be able to select a column then. All right, 2 more concepts and then we are done. So oftentimes you'll want to pivot or melt data. And pivoting data takes data from a long format, the long format that we're used to, and puts it in a wide format that's a lot easier to read. So this is a little bit more of a complex concept. So I will paste the code over here. So what we did over here is we told, we created an object pivot table, and we told it to go get the Netflix data frame, the pivot table method from Pandas, and index equals country. Okay, so keep country over here. Take type. So remember, type was like whether it's a movie or TV show, and make that our columns. Our new columns are movie and TV show. And then I want you to take the titles and then aggregation function, count them. So how many titles? So count the number of titles per type based on country. And then fill value 0. That basically means if you can't find something, like make it a 0. Because, for example, you may not have any TV shows in this country combination. In fact, we don't, actually. So if I change that to like 5 or 6, for example, you'll see these all change to 6s. Or if I just take it away entirely, you'll see they're an ands. But we don't want that. And you'll see I put that reset index in here also, just to clean up the data again. Remember, whenever you need to clean up your data, you can use just reset index. And so what we did is we basically took data that was going on a row by row basis, and we took a 7,000 column data or 7,000 row data set, and reduce it to 681 rows. It is similar to an aggregation, except what an aggregation would do, or what a GroupBy would do, is it would list type as another column over here. And you'd have Argentina movie, Argentina TV show. So this is an easier format to look at data, because we took it like this, because movie and TV show used to be one thing, and we made it like this. So that's why it's called a pivot. It's similar to like Excel pivot tables. And then melting. So melting is a very useful concept, because a lot of times I'll have clients that ask me they give me data in a wide format, which is, this format over here, because that is the format that like humans read data in. And they'll want to change to a long format because that's how computers read it. So what we have over here is a data frame that I just created pretty quickly. You can create data frames using dictionaries, by the way. And this is just the example from the Pandas website, because it's a very good one. We said df.melt, so basically take A, leave that as is, so column A will be left as is, and then count, and then take B, and then repeat it for every value of C that exists. So you'll see what we did over here. ID variable A, value variable B, and then variable name, my variable name, and then my val name. We just switched out the names over here too. You'll see otherwise it comes out as like variable and value. This is how you specify the names of the columns. And that's how you melt data as well. If you want a better example of how to do this, I do have a video on my YouTube channel. Let us see. Library. Ah, cool. Yeah, my top video right here. So I have this video over here. And this one, I actually show you guys like real data I work with, where I do a lot of like melting. I don't do any pivoting. I do some melting on it though. And what happens is you'll actually, now that you've done this entire course, you'll be able to follow along. And I think just about every function, every method I use in there was covered in this course. So I highly recommend you check that out, and you can see and try and follow along with the data set I provide over here. As you can see, I provide a data set in this GitHub link over here. That you can use that to follow along and really test your skills. So that's another data set you can use. And that's it. That is Python for data analysts. Now, what we did over here is we only covered what I would call the greatest hits of Python for data analysts. These are a lot of the stuff I use the most often. There's so much more to learn, but don't get discouraged. This is where you start. You start somewhere, and what I wanted to provide you guys with was a easy, or more than easy, a single place where you could go to find all of the what do you call it? All of the information you need in order to start your data analytics journey. A couple of years ago, I started off knowing nothing. I graduated with a degree in chemistry, and they don't teach you how to do any of the stuff in chemistry. But in a couple of months, because of some support from my boss and other people around me, and to be honest, on my own initiative, I was able to pick up these skills and use them to really derive great value for people. And I can tell you from real life experience, these skills are like if you're able to take these skills, just the Python I teach you over here, you can land a job in the high 5 figures in the US. And if you can combine this with some domain knowledge or another skill like SQL or Tableau or something, there really is no reason you can't charge people 6 figures for your skills. And you can take that to the bank. So I really hope that you got a lot out of this lesson. If you have any questions or comments, please leave them below. Please subscribe if you want to see more content that I put out. I really just do this because I want to help people out. I think that there is a lot of knowledge that I wish I had when I had started, and I hope that this helps you guys get started a lot faster. So thank you, and have a great day, everyone.